Yeah, welcome again to the session on what's new in Spring Data. My name is Oliver Gierke. I work for a company called Pivotal. Who has heard of Pivotal before? Okay, don't need to explain anything. I'm leading the Spring Data projects there, which means basically that everything data related that's not inside the core Spring framework itself is landing on my desk at one point or another, and I have to deal with that. And then work with a team of 4 other engineers on building a few data access abstractions and libraries for you. And what I want to do in the next 60 minutes is basically take you through a whirlwind tour around the latest releases. We usually do consider the last 2 releases because this talk has happened to be an annual one at our company conference, Spring One. And we usually do two major releases a year, roughly, and just want to give you an overview about what's new in them. So what is Spring Data in the first place? Who's using Spring Data already? Okay, so why are you here then? Yeah, funny. Anyway, what's Spring Data? Just for the ones that are not familiar and maybe the people that are watching the recording later on, we have the data access space roughly divided into like relational and non-relational space, where I think it's still remarkable that a group of technology defines itself by what it's not, right? That basically means everything that's not relational is in that other group. There's on the different abstraction levels, you have JDBC on the relational side. So with the Spring framework, that's why I put the asterisk there, you already get a bit more than just JDBC support. Much improved JDBC support, I'd argue, with JDBC template, which takes a lot of the pain out of JDBC that's in there. And on top of that, that's basically still like you do the mappings on your own. There's object relational mapping with the JPA specification, right? Also, already in the Spring framework, there's a lot of additional support for things that JPA itself doesn't really define to be possible, like we do entity scanning for you so that you don't have to list the entities in your persistence XML, and provide quite a lot of other convenience things around JPA infrastructure setup, basically. In the non-relational world, you, as a Java developer, you usually get a lot of Java drivers from a variety of vendors, basically. I just listed a few here: Couchbase, Cassandra, Solr, Mongo, what have you, and a lot of others. But the drivers usually end up, and that seems to be changing in the recent days, end up providing you a JDBC-like API. So you access the data store, you get some data structure back for example, in MongoDB you get DB objects back, and they don't provide any means to map your data onto objects. I think the Cassandra driver has some stuff in there already, so that's slightly changing, but that's been at least the landscape that we've entered a couple of years ago. And what Spring Data basically does is it puts a bit of glue on top of it, on top of the non-relational APIs, exactly what I've just mentioned, like the object to document mapping, object to graph mapping, what have you. And then like a thin layer on top of that to provide you a repositories API that makes it easy to work with the individual stores, right? That's something we add on top of JPA, which is what most of the users actually have started with, because it's so just kind of a no-brainer to use it and benefit from the abstractions there. But we don't have to implement the object relational mapping for you because that's done by the JPA provider. What does the Spring Data landscape look like? So we have a couple of foundational modules, like the Spring Data Core, or Spring Data Commons as it's called. And there's a new player on the field here, the key value module, which you probably might not have seen yet. I show you a bit of that in a second. But they act as a foundational modules for other, like the actual store implementations, like the next ones, right? So the store modules basically use Spring Data Commons or the key value module to implement the functionality. That basically allows us to easily change or add new functionality in the core module, which then automatically bubbles up into the other systems. And during the talk today, I'm actually going to show you a few changes that we did to the core that like support for Java 8 types that then nicely make it into the store modules, right? On the horizontal scale, basically, the modules you see here are all modules that are maintained by the Spring Data team. So that's the modules that we are actively working on. They are basically topped by a very special module called Spring Data REST, which builds on top of the repositories abstraction and allows you to easily expose HTTP or REST resources to the web, considering your domain model, right? So we're not like taking a database and inverting or circulating the tables by 90 degrees and then dump them into a JSON, but we actually inspect your domain model, take some or derive some knowledge that we can actually by the fact that you exposed some repositories, and turn that into HTTP resources. So that's the stuff that we basically do. It's like, what is it, like 8 modules? There should be, there's a few, like the build modules in there, but that's not listed here. But we also have a lot of community modules in the meantime. So basically companies or people in projects that realized, hey, we like the Spring Data stuff that we saw maybe with JPA, but we now have to use Elasticsearch. Maybe not have to, we want to. And we built some Spring Data Elasticsearch, Spring Data Cassandra module to be fronting the store, and basically allowing you or giving you the same abstractions and programming model for other stores. That space is growing. There's like there's a data store called Aerospike, which is sort of Redis-like, and they are just building a new module, and the Couchbase guys are busy doing a 2.0 version of their one, and Neo4j guys had 4.0 release recently, like a major revamp of it. So there's a very active community around these modules. They all use the Commons module, of course, and they all can be used by the REST or using the REST module. So what does the data module look like usually? Jesus, what's going on? Let me just quickly repair that. I was expecting Apple to turn it off for me anyway. So what does the Spring Data module look like? The very foundation basically is an object mapping module or a subsystem basically where needed. As I said, for JPA, that's already done for us. We add a templates API on top of that. If you're familiar with the Spring framework, at least, then you probably know JDBC template, JMS template, and what have you. So you probably agree that JMS template and JDBC template are JMS and JDBC are very different technologies. So it's not like a unifying API. But the templates both do exception translation and resource management. And that's what they basically do in all these areas, right? So we provide some general programming model which is consistent in different technologies. So you get that for MongoDB, for Redis, for Neo, what have you. Not with JPA because you have the entity manager there. And on top of that, we actually add the repositories programming model, which is like probably the most direct programming model that you interact with if it comes to the functionality. Here the templates basically do the object mapping for you, so you don't really necessarily need to work with the API directly, except you might be using our mapping annotations, but that's basically it. So having that said, we have of course deep Spring container integration with it, and that's what I want that slide to communicate. The core functionality is not really depending on Spring as a container. It relies on Spring as a library, of course, but that doesn't mean it's really coupled to it, which allows us to also provide CDI extensions for most of the modules, basically, so that even if you're running in a Java EE6 web server or application server with no Springs whatsoever, you can just take the Spring Data libraries, dump them into your class path, and use them with it, which is actually done by quite a few people, and yeah, that's basically it. All right. So that's just like for the introduction. Basically, I wanted to the code that I'm going to show you is in the first repo. I have the links collected in the very end. Actually, there's also a Spring Data examples repo that has more exhaustive examples that you can check out, and which I really encourage you to do, because sometimes we even get good ideas by people playing with the examples and then just reporting or asking for new features here. So just to give you a rough introduction, it's really supposed to be short here. What you do with Spring Data is you create an entity class. I'm using Lombok here just to replace an arbitrary amount of getters and setters with an arbitrary amount of annotations. And assuming you have your JPA domain type, you create an interface, let that extend a base interface so that the Spring container can basically find it by component scanning, and then you can declare so-called query methods, which I'm doing here, and we, or Spring Data, will go ahead and, unless you declare anything more special, it will try to derive a query from that method name, right? So it will, in this case I'm using JPA, so it will go ahead and derive the query select, what is it, C from customer C, where C.email equals $1 in this case, right? You have special keywords here that you can use with the property expressions that you have in the query method, and you can, of course, or you can also go ahead and you get API for pagination through your result set, which in case of JPA is quite important, because JPA is list based, and every query, if you execute the query, you get back a result list, which in case you're retrieving 100,000 customers, then you might want to order some memory, right? You see there's already a bit of support for Java 8 types, so we support them out of the box. We're still JDK 6 compatible, but if you're on Java 8, we recognize the optional type here to not return null if we don't find anyone with that particular email, and return an optional empty instead. I always mix up the methods between the Guava one and the JDK one, but anyway. That's basically it. You just bootstrap that thing. In this case, I'm using a boot app, and inject the repository, and then call the method here. I'm calling a save method, and then just try to obtain it again, right? The find one method, for those of you who don't know, is coming from the CRUD repository here, from CRUD repository, which is the method that the type that I've extended here. All right, so much for that. Probably not too much news for the people that already work with it. Just what I've explained as a summary here. What's new in Spring Data, the Gosling and the Fowler release? You could ask, what's Gosling and Fowler? I mean, I know Gosling, I know Fowler, but what's that got to do with Spring Data at all? We organize our releases in so-called release trains. As you've seen, we have to release quite a lot of modules, which actually develop because they are built by different teams, right? That evolve at a very different pace. So especially the community modules, which are of course usually led by people that are not, for which the open source development is not their full-time job. They are moving at a much slower pace than maybe the JPA and MongoDB modules that we work on a day-to-day basis. So we came up with this concept called a release train. Actually, we didn't really come up with it. The Eclipse team has been doing that for years actually. But we basically say, okay, let's group the releases of all these modules, in a 2 or 3 month cadence, and basically have milestones, release candidates, and whatnot. At a predefined cadence, and give them names, because the modules evolving at a different pace actually also means that, in the Gosling release train, the Spring Data Commons version is 1.11. The Spring Data JPA version is 1.9. The MongoDB version is 1.8, right? And that confuses people because they seem to assume, or of course assume, not really of course, but reasonably assume, that you might want to see, okay, if I use Spring Data JPA 1.9, I need Spring Data Commons 1.9. But that's not the case by the very nature of the modules evolving independently. So the release train names basically give us a handle where you say, okay, you want to use the Gosling release train, so you get all these modules in all these versions, right? So We had a Spring Data Dijkstra release train in 2014 that was on Spring 3.2, an Evans release train that bumped the required Spring version on 4.0. Fowler was on 4.02, and Gosling in September 2015 moved to the Spring 4.1 as a baseline. You might ask, and that's what I got asked this week for quite often actually, is why don't we, like, the current Spring version is 4.2, right? 4.2.2, 4.2.3 to be next week. And we get asked, okay, why aren't we like on the current version? We basically got the feedback that especially the people that are using the JPA module are often working in quite conservative environments that can't really upgrade to a new Spring version that regularly. So the guideline that we had for ourselves is that we always stay one Spring generation behind the current one and stay with 4.1 in this case, or we just upgrade it to 4.1, which basically means we require the latest Spring 4.1 version to run that thing on. You, of course, and that's the case for Dijkstra, Evans, Fowler, and Gosling, can run all of these modules on the most recent Spring version, right? It's basically just the minimum required version here. That actually leads to a question, because it's always good to get feedback a bit. Is that, like, for you, if you imagine we were releasing the Hopper release train today on 4.2, would that be a problem? Like, who could, as of today, upgrade to a Hopper that's on Spring 4.2? Who of you? Quite a lot. Who of you could not? That's probably even... Okay, quite a few hands. Even more so, requiring Java 8. Who of you is like could run his code on Java? Can run his code on Java 8 already? Java 8. Who is not able to do that? Quite a few. And by the end of Q4, who thinks you cannot be on Java 8 by next year? Still quite a few. Okay, because that we're currently planning, like, as you've probably heard from Jürgen if you've been to his talk, there's a Spring 5 plan for the end of next year based on Java 8, and we're planning to do a Spring Data 2.0 basically, or .next, like a major revision of it. And we plan to upgrade to Java 8 as well, which will probably mean that the version before, whatever that is, the I release train then, will be maintained for quite a while based on Spring 4.3, I guess, in that then. All right, that was helpful. So what happened in the Gosling release train is, as I said, that we upgraded the Spring Framework dependency. We usually take the release trains or the opportunity with the release trains to upgrade all our dependencies to the latest versions, right? So in this case, Guava 18. I mentioned Guava explicitly because it's usually causing headaches because it just breaks like APIs so very often. Jackson 2.6 hasn't been a too great experience either, to be honest. There's a few shaky things in 2.6, but we aligned to that mostly because there's this kind of Spring IO platform project coming out after boot 1.3 is released, and that's referring to Jackson 2.6. In terms of our ORM providers in the JPA space, we still support the Hibernate 3 generation. Who of you is still on the Hibernate 3 generation? No one. I'm sorry, but yeah, I am. But I guess we might want to cut this for the upcoming releases. That still means you can use the current version with Hibernate 3, and it probably even means that you can use the next version with Hibernate 3. We just might drop or move our build to Hibernate 4, which then basically just runs the test against that. But anyway, MongoDB 3.0 support has been quite a significant one in the platform in the Fowler release already. We've extended that with Gosling by quite a bit. So if you're running a 3.0 server or want to use the MongoDB Java driver 3.0, then that's supported with Fowler and Gosling. One thing that I want to show you and basically not spend too much time talking about in the slides is the release train bomb. Has anyone ever used the Spring Data release train bomb yet? do you even know what we mean by referring to a BOM? It's something that we actually got from the, or I spoke about the release trains and the version problematic, basically, right? And Spring Boot is basically solving that by providing you starter POMs and like predefined versions. But not everyone is really lucky enough to be able to use Boot already. So the Spring Framework and the Spring Data Team, and I think Spring Security does that by now, and Spring Batch and Spring Integration, they ship so-called BOM POMs, which not only sounds funny, but is quite useful. They are basically listing all of the modules included in the Spring Framework and define the dependency versions for that, using a dependency management section in Maven terms. And by using the in this case the Spring Data Release Train BOM, you can then go ahead and just define the dependencies to Spring Data modules without even stating any versions, and you can easily switch between the release trains without having to bother with the versions. So if you say we have the I just externalized that here, Spring Data version to set to Fowler SR2, and you see here you get the Spring Data MongoDB 1.7.2, like this thing, and the Spring Data Commons 1.10.2, right? You don't really have to know about this. You don't really have to bother. If you now change these that version number to the Gosling one, right, like this, to Gosling release, you see it automatically upgrades to Spring Data MongoDB 1.8 and Spring Data Commons 1.11. So you can basically refer to the very same notion that we use when we talk about the Spring Data Release Train, which really makes it easy to avoid the like version conflicts and stuff like that. Because we actually take the liberty to sometimes change things or change APIs in Spring Data Commons, because we know that they are only implemented with the other store modules, and take the freedom to move a bit quicker here, because it's not directly affecting your or the user code, but that still requires us to take these or to use the modules in matching versions there. All right. So what have we changed in, or one of the most significant things that we've introduced in Spring Data Commons is the enhanced support for Java 8. And that actually, I can show you an example of that. We've always, or not always, but have had support for optionals for quite a while. So if you know about the CRUD repository, like basically the repository interface that gives you like CRUD operations, like find one, save, and what have you, it traditionally returned a null object if it couldn't find an entity with a particular ID, right? So if that doesn't exist, it just gives you null by default in CRUD repository. In Spring Data Fowler, we added the support for returning optional here, so you can just like declare the method with optional as return type, and that will give you an optional empty if no customer with that ID exists. That of course also works with queries that would return just one result, and that's probably like there's probably more people with a particular last name, but you can just use that to basically wrap the null value or replace the null value. We also have support for default methods, which is kind of handy if you want to, let's say you have that method here by last name, and you also want to be able to just like hand in the customer into the method. Then you can just like have a default method that's forwarding the call to the actual query method. That's also kind of handy if you have a query method that takes 3 parameters that would, like in this case, all come from the customer object. You can then have an additional one that just takes the customer and basically unfold the customer into the method here. Just convenience, basically. The more interesting thing actually is, or the most interesting thing about the advanced JDK 8 support is the support for streams as return types. A naive implementation could just like go ahead and, like with JPA, execute the query, take the results, take the list, and then call stream on it, right? That would save you that additional call, but it's not really like a sophisticated solution to the problem, because like the streaming approach in the first place indicates that you rather want to consume the elements as a stream, right? So you want to read while you're handling them. And we actually implemented the support for that kind of method signature for JPA and Mongo already, where Mongo is actually simpler, because you basically get a cursor from the database, and then you can just wrap the cursor into a stream, and like while you're iterating over the stream, like pull data from the database. With JPA, it's a bit more tricky because, as I said, JPA is list-based. So we fall back, we basically detect the JPA persistence provider that you're using. And then if you're using, let's say, Hibernate, we don't use the JPA APIs under the covers, but Hibernate specific API to actually traverse the result and actually stream the data from the database. On the client, that basically looks something like this. A stream is something you have to close. That's why you have to basically work with it in a try with resources clause, and that's basically it here. Is it the MongoDB variant? Let me check that. No, it's the JPA one. Yeah. So in the MongoDB variant, like the difference basically is we're not reading everything up front, creating the objects, and then hand it out to the client, but just return the stream, and while the client is iterating over it, we read the data. For MongoDB, we convert the data while the iteration happens. So that's just in there. All right. Like a big warning sign for the JPA scenario here, that streaming the data doesn't necessarily mean you can now get rid of paging, because you're still like populating the entity manager or the persistence context, and it will if you read too much data, it will basically like read all the data into memory. It's just like, okay, it might be a bit more efficient to just be able to work on data already while the other stuff is getting read, right? The final Java 8 specific addition here is the support for completable future. Jesus. That's basically built on the support that we have, or that Spring Framework introduced for completable future, which basically asynchronously invokes the method and just expects the code that's returning the final result to create a completable future. So there's a bit of special handling in there, but it allows you to, let me go there again, to write code something like this. So you execute the read and basically define, with using a closure or a lambda in this case, what is supposed to happen with the result, right? So it's asynchronously executing the query here on the call level. Basically, you saw that that is at async, and that's basically the query execution is happening on another thread here, in this case, and then you get the completable future return type, which is kind of nice to handle, like what's supposed to happen if things fail, what's supposed to happen with the result, and you can just like basically chain the asynchronous invocations here. That's kind of neat. All right. So much for the Java 8 support. There's also a bit of additional support for the JSR 3.10 types, especially in the JPA case. I think that has changed in the recent times too. The JPA providers basically didn't really support JDK, local date time, local date, and what have you in the out of the box, right? Because there's no renewed JPA spec so far. But if the non-time zoned date time types can be safely converted into legacy date objects, which the JPA 2.1 providers can, of course, properly handle. And we're using the JPA 2.1 attribute converter interface to basically register the additional attribute converters, so that you in your domain code can use local date time, local date directly, and then just persist them, or make them persistable by Hibernate out of the box. There's also support for that for the 3.10 backport types. So in case you're writing code that's still on Java 6 or 7, and but wants to use the JDK 7 types already, so that once you move to Java 8, you only have to switch package names. We have attribute converters for those as well. All right, something that was kind of cumbersome was the problem of trying to extend your base repository. So assume you just have a repository. There's nothing in here really that's to be shown, but the CRUD repository that we're extending in the JPA world is implemented by a thing called simple JPA repository, right? And that, for example, implements the find one method. So it's doing a bit of like, in this case, like just like locking checks and hint checks, and then just executes a query. Fine. But some users, or we had always had support for customizing that, right? Like that functionality by simply providing an extension of a simple JPA repository in the JPA case, or like for all the other stores as well, and then having some means to hook that implementation class into the Spring Data infrastructure to let that use your implementation class. And that's always been kind of a bit of a hassle, because you had to implement the factory and the factory bean to let that work in Spring, and then the one calling the other. And it's been quite a bit of boilerplate that we required you to write, and we actually were able to dump that down quite a bit. So you see here, what I'm doing is I want to customize the find one method. Logging is probably not the best example here, because you could just use AOP or something to actually call or add logging to that. But let's say you want to do something special to the find one call here. You just create a class that's extending the original base class of your store, and then is mimicking, and that's an important bit here, is basically mimicking the superclasses constructor. So there has to be a constructor that just calls super with the JPA entity information entity manager. For JPA, of course. For MongoDB, you would just go extend simple MongoDB repository and do the very same thing. And what you can then do is just in the JPA configuration, like in this case, I'm again using Spring Boot, but explicitly activating Spring Data with a custom repository base class, right? So that would basically trigger Spring Data to take or to create instances of custom base repository and not simple JPA repository to back your class. It's a bit weird to demo, because it just looks kind of neat now. And if you've never been exposed to that and never seen the mess that it was before, then it's kind of okay. What's that? But if you just compare the reference documentation from what you had to do before and what you have to do now, and people that really needed to do that were quite happy about that. That's basically the summary here. That's it here. Okay. Web projections. There is there's been some code in the Spring Data REST module that I show you in a bit that had some API where you could easily create projections onto objects. What does that mean? Like in the Spring Data REST world, we take your domain object and create some HTTP resources for it, like /customer/customer/1, and they by default serialize most of the properties as like into JSON fields, right, and nested objects and what have you. And sometimes you don't want to expose all of the fields of them, but only some, or sometimes you want to add a few fields with calculated data or what have you. And the means that we provided in Spring Data REST originally is that we have API to just create an interface. We love interfaces with Spring Data. You probably should know that by now. You create an interface. Let's say you have where is the user class? The user class looks something like that. It has a username, it has a password, it has an ID. And we want to create a view on the data that consists only of the username, right? So you can go ahead and declare an interface and say, get username. In this case, I'm not really like letting the, if I remove the value annotation, it would just forward the call to the target later on. But what I'm doing here is I inspect the target, take the username property, and call toString on it, right? So the question is, how do I create an instance of that thing here? Like, how do I create the projection? And there's a projection factory interface that we provided in Spring Data REST in the first place, but now move that to Spring Data Commons because it's kind of helpful. Even if you're like just writing REST APIs with Spring MVC, you sometimes have the need to like create these projections, and it seemed generally useful, so we just added it here. So you can basically say, okay, create me a projection. Here's the projection type, and that's the source object, right? So that's kind of helpful in this in case of the combination with another thing that we did to Spring Data Commons. We extended the page interface, right? The page interface is basically the result of a pagination request, and it's got a map. Method that takes a Spring converter, and the Spring converter interface is a kind of a neat thing on Java 8 because it's a single, it just has a single method, so that it can be used with a lambda. So what this piece of code here is basically saying, give me all the users. In this case, like strictly saying page 1 by a page size of 10, and then for every user in there, map this thing to a projection, right? To the username projection. And then give me the content of that, right? So it's basically creating, in this case, proxies for the interface that will route all the calls to its accessor methods to the backend class, or in this case here, evaluate the add_value. That's the Spring add_value annotation. And basically expose that. So if we hand that list to Jackson, it would just serialize it as a plain Java object, and will return just the usernames in this case, right? So that's the reading side of things, sort of. Another thing that we realize is that oftentimes, like for forms, you need to create a Spring Bean base, or just a Java bean where you bind request values to, right? And it's kind of a pain in the ass to create all the properties and then have getters and setters, and just like basically it's a DTO basically, right? To bag a form to. And I know you can use Lombok to get rid of that, but we wondered, okay, doesn't it like, why would I actually need to provide these setters and these fields? Because on the controller side of things, I just want to express which data I want to get from a web request. And I can do that using an interface providing accessor methods, right? So I can say user form, get username. I want to read the username property from the request. I want to read the password, the repeated password, and what have you. And what we did is we basically added support to Spring MVC that allows you to just take the interface here, in this case, take a parameter of that interface type, and because it's an interface and not like actually a class, we hook into Spring MVC to then use the proxy, the proxy projection factory in this case, to create a map and bind the request parameters to a map, which then will allow you to access them via these methods here, right? And that's quite neatly combinable with some validation, right? Interfaces have a default method in here, and call the methods and do, like in this case, a multi-field validation. So check whether that the passwords match or not, and even call like in this case a Spring Bean here. Where am I calling that method? Right, so I manually invoke the validation here because I need to pass some Spring Bean into the validation. But that's I think it's very like, what is it, requirement oriented. So I want to use that or pull that data out of the request, and I want to validate it, and then I just create my domain object eventually and persist that. All right, so web projections. Got that? Okay, so yeah, I said the projections can be backed by an actual object or just a map that would just like naturally be nested and stuff. That's in here. If we're in the web space, a very recent addition has been the Kroy DSL web support. Who of you has been exposed to Kroy DSL before? So who knows what Kroy DSL is? Oh, that's more than the last time I've been here. That's good. Kroy DSL is basically an improved version over the Criteria API. It also creates a meta model from your domain classes and allows you to write, let me check whether I don't have any test cases here, I guess. It allows you to write expressions like, in this case, let me go here, Q user, should that work? User. That's basically the meta model type that I've generated using an APT generator during the build. But it allows you to say user.firstname.contains foo, and that's like assignable to a Boolean type where you can then say contains and yada yada yada. So you could go ahead and say user last name, what have you. You see, that's kind of fluent, it's kind of easy to combine, and it's very easy to execute by just, in our case, if you know the Spring Data repositories, they can extend a Kroy DSL predicate executor. Welcome to the world of Spring class names. To take a predicate and then basically execute that predicate definition that you've just applied. So something we've been wondering quite along is whether it might be possible to just bring that to the web, right? So basically take request parameters, something like, in this case, user.address or address.zipcode, and then bind that to something. And actually, let me run this thing for you and actually provide you a predefined predicate. And that's actually what you've seen in the user controller already. Yay. Yeah, there's already a Tomcat running. There's not. There probably is somewhere here. I just ran one when I tested the demos. There we go. Anyway, I just show you the APIs, that's fine. There's the MVC integration basically is allowing you to take a Kroy DSL predicate that defines, okay, I want to bind any parameters that could be applied to a user, basically, and provide a predicate for that. And the question is, how do you bind an expression like, in this case, address.zipcode, right? Is it like the default binding in this case is using an equals predicate, right? So when you provide address.zipcode, something like this, address.zipcode equals 4711, we would just create a predicate for that just reflects exactly that, right? So, and especially for string parameters, that's usually not the thing that you naturally expect, because like if you have a web form or something and you type in some, like you want to search by last name or something, you usually rather expect a contains mapping. And there is there's an interface called, what is it? Kroy DSL binder customizer here, which we implement using the default method here, that you can provide or just implement with your repository actually, and then customize the binding. So what I'm here expressing here is that all parameters that are string parameters or of type string, I want to take the first parameter and I want to bind it using that lambda here, which is path.contains ignore case, right? So whenever I just type like lowercase new, then it would, like for a city, find New York and stuff like that. You can also exclude properties from binding. You can define bindings.bind and then use the root thing that you just got here, root.last name should be bound like first and yada yada yada, right? So you can define explicit bindings for explicit properties, that's fine, and then you can just say, okay, for all the ones that I didn't define an explicit binding for, I don't want to bind at all. That's something that we actually recommend if you're not providing any in the first place. So you customize the binding using that callback interface that uses lambdas heavily, and then just get the predicate injected into the controller method, run this, and all you need to do is basically execute that. right? That's kind of helpful. That is available to Spring MVC out of the box. It's also shipped with Spring Data REST. So when your repository already implements a Kroy DSL predicate executor, you can just like query the data using that mechanism and filter the collection resources. All right. In the Spring Data space, I probably just skip this demo just because of the lack of time. We have added support for ad hoc entity graphs. If you're familiar with JPA, then JPA 2.1 introduced the notion of so-called fetch graphs that define which parts of the domain tree you have or the domain object tree you want to load. It's a bit cumbersome to use. There's been some feedback to improve that. That's why I linked the ticket from the JPA 2.2 bug tracker. And we provide some workaround for that on the repository level, so that you basically just whitelist the properties you want to load, and get that loaded. Spring Data JPA in its current form should be ready for Hibernate 5 usage. So there are examples that run on Hibernate 5. We work with the Hibernate guys to during their beta phase to eliminate some issues that occurred there, but that just works. And as I already mentioned, we added the attribute converters and attribute converters for the JDK datetime types. Improved support for stored procedures. Anyone executing stored procedures through Spring Data repositories? All right, fine. Spring Data MongoDB. There's been that kind of functionality here, that the Spring Security integration into MongoDB has been in Spring Data JPA for quite a while. We basically took that forward to the MongoDB module, which basically means that in a manually defined Spring Data MongoDB query, you can now use spell expressions, and within those spell expressions use security expressions, basically. Well, not security expressions only, but basically any kind of expression, or there's actually an SPI for that, which Spring Security uses to register its security functions for the usage with Spring Data query expressions, right? There's an SPI, evaluation context provider that you can just implement, and even if you want to make some function, some code execution available to your MongoDB queries, you can just write your own one and then register a spell function or something that you could evaluate in your query definition. In this case, what it's basically doing is it just says, okay, whenever this method is executed by an admin, I just wanna return I want to look up the current user, or when it's an admin, I just want to check that the ID has exists at all, right? Which basically means give me all. All right. So that's just the security declaration here. That just works in manually defined queries, of course. The other thing, which I basically already mentioned, is the JDK8 support for MongoDB, which basically means stream APIs. In that case, it's a bit less problematic than with the JPA case, because we get a cursor anyway from MongoDB, and the cursor has already all the data ready that we want to read, and then we can just where is that sample? That's actually kind of neat, because it shows you the difference between the two execution models. Let me just run that. So you see, in one case, it's reading the data, and it's where is it? Before convert, on after load. So you see the events on after load, on after convert are triggered first, right? So we load the data, we convert the data into objects, and then we hand it back to print it out. So that's basically the client then getting the already converted data. With the streaming approach, it's interleaved. So we hand back the stream, and while the client iterates over the data, we load the data and convert it to objects, basically. That's the thing that you get out of this, like calling find all with the list and for eaching over it versus using a stream. That's basically the difference. Okay. Got that. You can hand in JavaScript functions into the MongoDB, so either execute it on the fly or just like store it into MongoDB and execute that. As in here, 3.0 driver compatibility I've already mentioned, and there's also support for GeoJSON basically, so a dedicated format for expressing geospatial objects like points or shapes or what have you, in both persisting and using them to query data like bounded box queries and stuff like that. That's supported here. All right, Spring Data REST. As I said, Spring Data REST is basically taking your repositories, executing creating HTTP resources for it, for each of the repositories, and then allowing just HTTP clients to consume them. Something that we've been asked for quite a while is, that we've had, is the support for, or you could of course go ahead and create Etags for your HTTP resources, which means you basically create a checksum of the state of your object and put that as an Etag header into the responses. And that allows the client to basically ask for two things. It could ask for, give me the resource only if it's different than the thing I already got, right? So with an if non-match header, basically say, give me the customer if it's not matching that checksum anymore. Or you can say, put or update that customer, but only if it still matches, right? To avoid that you overwrite data that has changed on the backend. And that's what we're now doing. Or the checksum approach has the drawback that you actually have to load the object from the database and then have to turn it into some JSON and then basically hash the representation and return that hash as the Etag. With optimistic locking in place, like using an add version attribute in your domain object, we can basically skip the latter part and just check the actual version and use the version as the Etag, right? And that's what we're doing here. So just let me go here. So what Spring Data REST is now doing, where is it? That's the customer. The customer has a version attribute. That's something that's important to notice here. It also has a local or a last modified date, that's something Spring Data specific. So it gets the modification date set on every persistence operation. And in the test, what I'm doing is I get the first customer, and I do a GET request on it, and then make sure an Etag is set, like that's the version here, and the last modified header. And in this test case, we then say, okay, only give me the customer if it does not match the Etag that we've just got, and that should yield a not modified response in this case, right? Because we didn't change it so far, and the header is still present. The very same thing here is that we could ask for, oh, give me the customer only if it's not been modified since that very date here. Alrighty, so that's the Etag header stuff and conditional requests, Hell browser and metadata. Let me check what we actually, if there's a Tomcat running, I should be able to see what I have running there. Yay. It's not running, but it said it was running. How does that work? That could be I think it was using MongoDB, wasn't it? That could be just my bloody MongoDB server. Anyway, let's try to run this one. So what we're talking about here is that when we expose REST resources from our repositories, we actually like the Spring Data REST looks something like this, localhost 8080. That's just the website. Let me just try that again. Yes, sorry for that. /API. So is that readable in the back? I hope so. So I have in this case, the example is basically a giant CSV file of all the Starbucks shops in Northern America alongside their geospatial data. And I've created just a store class here that has an address with the very location. And I have a repository that has this single method here that's saying find by address location near, and it takes a reference location and a distance. So basically give me all the shops in like 50 kilometers distance from that very point. And that's basically everything that you need to really query a MongoDB for geodata, which is kind of fun, I think. And that's exposed as an API using Spring Data REST. So you just put Spring Data REST on the class path, and it will allow you to just like query the stores. It's doing pagination, as you can see here, with the first link and the next link and what have you. And it's also, so you get basically an API, HTTP API, to manipulate stores and add them. And it's also exposing metadata about the stores, like because we have to analyze the domain object anyway for like relations to other objects and whatnot. So you can go ahead and say, I want in that profile resource, we basically store information because that's what the profile link relation is all about. But schema plus JSON. We expose a JSON schema, right? So some metadata about the actual structure of the object. And what we've added in Spring Data Gosling is that there's a thing called the HAL browser, which is just a general JavaScript application that you can point to any REST endpoint that supports HAL. And it will put some nice kind of UI on top of the REST service to explore it, right? So you see there's this stores link coming back, so it shows up here because it basically understands HAL and makes you use that. So you can follow that link and get like all the stores back that are in here and stuff. So you get a bit of nice UI. And the interesting bit is that, or we've customized the HAL browser to use the metadata to not just give you a, let me just go here again, follow that and say stores, like take the self link here, and if I do a non-get request, you usually get, whenever you want to post something or put something, you just get a JSON, like an input field where you have to put the JSON that you want to send to the server. We've customized the HAL browser that for a non-get request for the stores resource, we actually inspect this JSON schema and then give you like a form that just takes the schema, turns it into an HTML form, and then basically allows you to submit post requests and stuff like for your even maybe complex domain object, and you just get that out of the box by putting where is it? That thing on the class path. That's basically the HAL browser in consumable form. That's it. All right. So I actually that's the summary of what I've just told. There is a Spring Data key value module. I probably just skipped the demo. We've extracted some functionality into a new key value module that all of the modules that basically abstract key value stores like Redis or coming up Hazelcast and whatnot are going to use to build repositories on top of key value stores. Let's skip the demo here. It basically assumes that all of the data that you have in here is or can be stored in some map implementation by default, and for testing purposes we just provide an implementation that's using a concurrent hash map, and that still does query derivation using the Spring expression language, which means that you can still query your data like you're used to with JPA or whatnot. So what's coming in the next release is we're still working on something called query augmentation, which basically would allow you to implement things like soft deletes in repositories, or basically secure your entire repository with say, okay, you want to have ACLs or something on your repositories. We're working with the Spring security team there. Christoph, like my colleague, is working on Redis object mapping basically, and there will also be a Kroy DSL 4 upgrade, like a major upgrade in the Kroy DSL library, plus some major revamps in the store implementations. All right. What I'd like you to do is, or if you want to play with the samples, feel free to do so. It's always helpful to get like tickets with suggestions and stuff. And I ran across a funny thing on the internet recently, which is like the most credible tech authority you can imagine, named Jessica Alba. She was in a YouTube interview and she was asked, "Are you a tech person?" And that's what she answered. "I do not know how to code, but I can put in a Jira ticket." And I thought, if she can do that, you probably can too, right? So because I meant just mentioning that because there's a lot of people that come to me and say, "Oh, that doesn't work right, like I expected," and they say, "Did you file a ticket?" I said, "No, I didn't really." Go ahead, do so. File tickets and provide feedback. You want to check out the video? Does that even work?
Are you a tech person? Are you tech proficient?
I do not know how to code, but I can put in a Jira ticket.
Okay.
I like that. That's kind of cool. All right, so the resources for all of the stuff I've shown you, we are quite new, not really new on Gitter. So if you want to get in touch with us, feel free to just get there. There's the links behind all of that, and just go there. And I'll be around until for today only. I have to fly out by tomorrow morning. But if you have questions, just come by and yeah, that's it. Thank you very much.